Alright, so I went ahead and changed out these 1 amp diodes I had for some like 40 amp shotkeys. I pulled off some power supply. I just kind of tacked them on there. This is going to be the last video that I show going over this particular circuit. Hopefully, I haven't like drawn a diagram or anything, but I sort of tried to show what was going on, sort of step by step. So I guess now I'm just sort of going to go over what I ended up in the finalized version of just the feedback network and all that stuff. And I guess I'll say, based on some load testing I did, yeah, it wasn't too great. I'll kind of show that. But, again, it accomplished what I was trying to do with it. The reason it looks like a monstrosity is because I didn't know what the hell I was going to do. About several times halfway through building this damn thing, I thought I was making a half bridge. So I guess I came into it thinking like, yeah, I'll just do a half bridge. But then I guess I thought about it, at only 24 volts in, that wouldn't really be the best idea. And I guess it's kind of more of a headache. So then I switched over to push-pull and realized, hey, this would be not too difficult. It's fairly simple in practice. It doesn't need to be crazy just to get some basic supply you're not pushing crazy power from, right? And while it did end up being a little more complicated than I wanted it to be, that was mainly just because I was just sort of, feeling stuff out. So next time, I'd say it probably wouldn't be that difficult to throw another one of these together since, I'm just basically, I had all these parts and I decided to try to use them. I can just make another one. Basically just try to see if I can, really tweak this section right here using this opto feedback, the PC817, and then the TL431, right? Basically, I can see that the way that I got this divider set up, I can get up to like 24, which is pretty cool, but I like to actually go lower than 12 now because I guess that'd make it easier to load test it, like maybe throw some low value resistors on there and stuff. It'd be easier just to kind of crank it, from the lower voltage. But since I'm using this TL431 and the TL494, I'm only going to be able to get 2.5 volts out at the lowest, I guess, right? Because the 2.5 volt reference. Well, see, I actually thought I had this wired as a 3-pin divider, but it's actually already rheostat. So I guess I got like reversed on which direction I was going there. So basically, I just have to have to be able to trim down more. So I basically just had to replace my 10K pot with a 20K to be able to go all the way down to about 3.5 volts. I really don't want to go lower than that anyway, because then this little voltmeter I put on here starts going out, because I don't want to reference it. I don't want to power it from the other side, right? Alright, so swapping to the 20K let me adjust my voltage down to, where I wanted, but that ended up burning out the TL431, so I had to replace it. So I'm going to see if I can adjust some values to keep that from happening. And but also, this thing was switching real bad on the lower end, and it was getting pretty inefficient. So I guess one thing I'm going to do is just throw a little kind of output load resistor on there at all times for one, and then go from there. Alright, so if I recall, I was bringing the voltage down to like 3 volts, and I was looking at the my supply, and it was kind of triggering. I saw the CC light triggering for like split seconds, and I guess what was happening is at the lowest voltage, it didn't really have enough current. I suppose it kind of lost feedback, or it was getting wonky. It was either that or like I don't know, some type of spike managed to make it back through into the rev pin. I don't know, right? So basically what I'm going to try to do is give it some kind of like fixed bias to make sure it doesn't lose sense, and then maybe try to like throw some like little baby TVSs or something on there, like little Zeners, to try to keep it from getting zapped. And then I guess, I don't know, maybe then I'll bring it back down and see if it dies again. So I just put I put a couple 1N4148 switching diodes on there. So I'm not going to bring it all the way up to 24 right now, but I guess what I'm going to do is, I found these 2.2 ohm resistors, so I just made a 4.4 ohm resistor. I'm just going to run the output with that, and I'm going to bring it to about 40 watts. So I'm going to put about 13 and a half or so volts on it. just to kind of, see how that goes, right? So I'm at 17. I've got it set. So you can see it's still spiking at that load. It's not really running great with that load. But 13.3, so that'll be just about 40 watts. So I'm pushing 50 watts in there, or 52 watts at 17 volts, just to get that out. So, obviously there's lots of little variables like, what your input voltage is relative to your output voltage and the kind of current you're trying to push. So I'm not really sure if I'll be able to work this out too good. I can't really put a minimum load resistor on there and expect the output to be kind of tame. So maybe I can kind of show, I just kind of wanted to see what that would do. Pushing 50 watts in, about 40 watts out, just for like a couple minutes, and just kind of maybe see what's getting hot. Because again, I don't have any heat sinks on here. I guess it's kind of pointless to try to push more power. But something like 40 watts, whatever, that's all right. Like I see, these guys are starting to sizzle, or they are getting pretty hot. I don't really think the circuit will be getting too hot yet. Just again, remember, this is 55 volts, so it's going close to like 80 still on those guys. So it's more like, I've noticed it's not so much a load thing. I have to bring the voltage up. So like even when unloaded, so long as I have the voltage up, then it seems fine. Anyway, feel like the slightest warmth on this transformer. Whoops. Those resistors are still smoking like crazy, but and I also feel just, the slightest little bit of warmth on the switches. It's only kicking out 3 amps at about 13 volts. But still, that's not bad. So, I don't know. I might have to heat sink that. 50 watts in, 40 watts out at that particular setup. Not too bad, but not too great. All right, now back at 15 in with the same load on. I kind of want to see what happens when I bring the voltage down. So you see with 15 in, I can only push 40 watts in, 11.5 out. So I'm going to start bringing it down. And I can hear the core start to, so there's a lot of low frequency crap going on when I get too low. Is that going to kill it? I don't know. But that is what I'm noticing anyway. So again, the thing is, if I bet, I feel like with this setup, it'll get too hot. But if I push 24 in and load this like that, it might be all right. I don't know. I can try to just keep raising the voltage where it's at. And so I'm reaching the hard limit here. 20 with a 24 in, it's just maxing out at 14.3. It won't go higher than that. Whoops, I wasn't even paying attention. You have to excuse my bone brain overlooks here sometimes. Halfway sleeping through this. I had the CC on, so I kept thinking it was hard limited. So I cut it up again. I'm gonna get it going again. So it's 52 in. I'm putting 13. So again, about 40 watts out now. I'm gonna leave the wiper all the way up. So I was CC'd at 3.5, so I can't actually keep pushing more out. So that's like 15 out. So right there is my limit. 15.8, 72 watts in. All right, so at 50 watts in, I got about 40 watts out. At 60 watts in, I got about 48 watts out or something like that. And then at about 70 watts in, I'll say I got about 56 watts out. Right, so you can kind of see what's going on there. But it did put out a little over 50 watts, at about 15 volts. So let's see, about 3.5 amps, 15 volts. Based on that, I guess if I wanted to do like a current overprotection, I would just cap it at about like 3 amps or something like that. But I guess maybe I kind of want to use this pot as a current control of some kind. I don't really know. At this point, I'm kind of thinking I should have just rebuilt this thing on another board where I can heat sink everything better and actually try to go for higher power, because it's not really making a whole lot of sense at this point. But all right, so now getting into what actually killed this guy. I just placed a couple switching diodes on it, but I just put a random 100 nanofarad capacitor on there just because I had the understanding I needed one. But I guess I really didn't think about it. And looking at it now, there's some things you can read on this that'll tell you that this is just Google AI, but the stability of this loop that you're trying to make with this thing, it says right there, well, it could be stable in a very low end and a very high end, but not really in the middle, right? I guess it really all depends. Just throwing a random value on there is probably, and maybe it could work kind of like it has for me, but it could also cause a lot of problems. Then, of course, the problem is, I don't know if I can zoom on this thing. I've actually put it in the wrong spot, because the way I've got this thing in there, it's going to be ref anode cathode. So I've actually got this capacitor across the anode and ref, right? So that was probably causing some problems right there. All right, so if you go through this PDF from Texas Instruments, they're kind of explaining the same thing. It's like, look, you you kind of need to pick a region, very low or very high. If you ride in the middle, you might run into problems. But they say right here, any cap could be used if a series resistor was added to create an output zero at a low enough frequency. So it's kind of like they're saying, you can't just throw a random cap on there. The ESR needs to be right. But I guess they're kind of saying like, well, you can sort of hack that a little bit and tweak it. Now, I don't really. I guess I need to kind of go into that, honestly, but I'm sort of just wondering if just removing this capacitor that I actually put in the wrong place would make it fairly stable. If I'm trying to really focus on the feedback loop, which I guess is kind of necessary if you really want to make it a good converter. Yeah, I guess that'd be a thing. So maybe I should go through this a little bit more. So they're basically telling you with a certain capacitor value that you're using, I guess across anode and cathode, and you can add a certain series resistor in line with it to get your feedback loop a little better stably tuned, Now, I guess you have to pick your chart. So one of the things I'm just kind of starting with is I'm just running a 10K. I'm not sure if that's the best value, but I'm just running a 10K off the Vout plus on my output side, going to the cathode. I've already got this 0.2K through the LED going there, but I've added this 10K just to kind of always keep a little current fed into it. I don't know if that value is going to work, but I guess the idea is, it always needs to maintain a certain amount of current flow. So let's say when I'm at the really low output voltages, then yeah, these values I've got might not work so good. For example, I could tweak this capacitor, this resistor right here, this current limiter, into the opto side. I've added this little load resistor, but at the end of the day, it's kind of like, well, what the current is, what I'm feeding through here at my lowest designed output voltage kind of needs to make sure that this loop stability is there still. So again, like I say, I'm just sort of kind of keeping it fed by that. And I guess I'm either just going to say screw it and not use a capacitor at all, or otherwise I'm really going to have to kind of look into this real closely and figure out how to analyze these charts and really figure out what type of resistor I'm going to need and capacitor. So I guess essentially I could use something like this if I kind of go by what that chart's saying. I suppose that I could look at it as this is would be sort of my lower worst case scenario, and which is what I saw the problems at, right? So I guess if I'm pushing a good amount of opto current at my output at the higher voltages, then I would imagine I'm dealing with the higher. Well, it stops at well, never mind, it goes up to 15. I would imagine I'm dealing with something closer to this, right? But if I'm worried about it sort of dropping out and not being able to keep a loop going, then I would imagine I might sort of go for something like this. So I guess let's just say, what did I have? I had randomly put 100 nanofarad on there, right? So I guess if you're dealing with under 10 milliamps, so let's just say this right here is kind of showing you all the way up to 3, and then a little bit higher, but still under 10 milliamps. Or excuse me, 10 milliamps or greater. Let me zoom in. So if I had that random 100 nanofarad, then I guess you could look at it like, depending on, you know, the current. So like I'm using like a potentially 24 volts out, but then down at the lower ends with the current that I'm feeding it, I'm probably looking at closer to you know, this middle region here. So let's just say around, what's that? Around what? 5 ohms or so, right? But I guess you could go all the way up. So let's say anything about 10 milliamps or greater, then I could go about, you know, 5 or 6, right? But then down at purple, you know, 1 milliamp or so, then that's going to be well over the 10 ohm ESR, right? Kind of compare down here to the 15 volts. So I was looking at the 2.5. This is the anode to cathode voltage. When I first looked at that, I was like, VKA, like makes you think of KVA, but this is the voltage across the cathode and the anode, right? So I was looking at the 2.5 volt chart. So now let's just say I'm looking at the 15 volt chart, which I guess is kind of confusing, but like the voltage across your anode and cathode of this thing at the time does not necessarily dictate the current flow, right? So that's why they have these different charts. Well, let's just say now, what did I say before? If I'm like going around the, I think I said like the, I gotta look at it again. So let's just say if I was over here, here goes the 2.5 one. If I'm going looking over it, let's just say, okay, if I am running down close to like a milliamp through this thing at only about 2.5 volts across the anode and cathode, then I might lose I might have too much like phase shift to where I lose stability. I guess they're saying in order to, you know, fix that problem, or it's like, okay, anything about, you know, I don't know exactly what that is, but some degree over 10 ohms, you know, let's just say 20 ohms or some crap like that, 15. And you should be good there, whereas like down to about the 5 or 6 ohms is fine for anything roughly over 10 milliamps or greater. That's their recommendation. So then you look down at the 15 volt one right here. You can see it shifted up quite a bit to where with that same capacitor, if I've got the 15 volts across the anode cathode, then, you know, my equivalent series resistance needs to be fairly high, so I'm not dropping out and getting going nuts. I mean, it's not guaranteed. I guess this is all just like recommended stuff, you know. But running down at that milliamp or so, I'm gonna need a good bit of ESR on there, right? So that's kind of cool, right? So I guess what I'm just gonna do first is just remove it completely, right? And then not worry about that, and then maybe kind of see what it looks like at about, you know, 15-20 volts in when I try to bring the output voltage back down, right? All right, so it actually seems slightly more stable. So I'm just at 15 volts in, and you know, no load. It's probably switching real bad, and as I'm cranking it, when I was cranking it before, I think as soon as I started to go below about 8 or so volts, I would see my CC blipping on here just super fast. I couldn't catch the reading, but I'm sure it was, you know, it was limiting, obviously. And then it's about when I get to, you know, 3.6 or so, I can hear it start chattering, right? So I don't want to leave it there. I don't really see any problems with it until I get down that low. So, you know, what I might end up doing is just not worrying too much about that. Am I really going to run under 5 volts out of this thing? I mean, maybe. I can't really get as low as under, you know, approximately 2 something volts because of the reference, but maybe just trimming it at 5 would be fine, right? So that'll kind of limit my bottom end. Now, I don't know. I could have, that chattering, see, I'm at 15 volts right now, right? So let's just say I was at 24 and I brought it all the way back down to where it started I could hear it chattering real bad. Well, maybe I would have killed the TL49 or the TL431 again, right? It's possible. And, I put the little 1K on there. I doubt that's really doing anything, right? At least with how this is set up. So I think that's what I'm going to do. So now I'm just going to not worry about that capacitor for now. I'm going to just trim that down so it doesn't go below 5. And then, go from there with load testing. And if I start going all the way back down to 5 and I see issues, then maybe I'll consider that. But it is kind of cool. Again, if you're worried about, the loop stability there, I suppose that is a kind of a cool trick they're telling you. When you add the capacitor anode to cathode, they're basically saying you're creating a pole, which could cause a shift. And, you're dealing with, okay, well, you might need to tweak that just right get the right ESR in this capacitor that you've added. And I guess more or less it's sort of like a hysteresis, tweaking the phase so you can maintain a proper feedback loop between these two references. And, again, I'm maybe that's something more for people who are really giving a crap about their converters. I don't really care so much about that with this, but, again, it might be something that I mess with later, right? So I guess you can look at it this way, right? I've got a limiting resistor into this opto here. So you basically got two different things here. You've got the opto LED that needs to be able to switch properly, but then you've also got the TL49 or TL431, which always needs a little bit of current. I think it starts wigging out at about like a milliamp or something, right? And I think it's going to probably be the same thing for this opto. Like, I probably should look it up. But, I'm pretty sure once it gets too low in current, you're dealing with an issue of this being able to work properly as well as this losing stability, right? So it's like, even though maybe I'm kind of trying to keep the cathode fed with a little bit of minimum current by adding this little 10K right here, right? That doesn't really do anything for the opto once I'm too low. So again, it's kind of like, maybe I could play around with that, but it's like, well, I know I'm running 24, right? So at the upper end, I'm going to be pushing a certain amount of current. I don't really want to go over that. And at the lower end, I might be pushing too little. So while I probably could just do that, I'm seeing I'm barely maybe not getting enough on the lower end, right? So I could decrease that slightly and then still maybe not overdrive it at the higher outputs. But I suppose maybe the simple solution here, because like I say, I'm probably not going to run less than 5 volts on something like this, right? So I'll just trim it down to 5 volts. So what I'm going to do is, since I've basically replaced this 10K I had with a 20K, I removed my 8K series. So that allowed me to basically trim this all the way to 0 or up to 20K. I don't really need to go that high. Whereas before, the lowest I could go was about 8K series, right? And this allowed me to go all the way down to 0, back up to about 18 or so where I had before. I'm just going to throw a little smaller series resistance in here now to just sort of trim closer to what I had, but still be able to go down to about 5, right? And I'm just going to call that, the solution. All right, so I guess that is just going to be my fix, where I've added another 2K in series with the top end of my little divider down here. So you can see, shorted on the input there. You can see now I've just got a lower end of 4.5 volts, right? So it's just about a volt higher than it was, but that keeps it from going into chatter mode. So I'm just barely pushing enough output current into my feedback stuff there where it doesn't wig out. So I really am not going to worry too much about that TL431 anymore based on that. But, it would have been nice to go down to maybe 2.6 volts or so, but I don't really care. What am I to do? Like put LEDs on there or something, So again, I still got my full adjustment, and all I can go down to is about 5. So 24 to 5 from about 24 volts in. What was it? 50. No, I got about 56 watts out max at about close to 70 watts in, right? So we're looking at less than 80% efficiency, whatever. I feel like that's not a bad approach, a little push-pull approach. I would say if you just use 75, 100 volt FETs, then you really don't need to worry about it as much as I am. And, you know, I could have left a little, maybe I don't need shotkeys this damn big. But it seemed like that, yeah, that worked fine for a little supply, right? A little isolated supply. That's pretty cool. Most of my stuff is using buck inverters, right? So that'd be sort of a cool little difference to see all these little tiny supplies I've got. Like this guy with the battery, of course, that is isolated. You know, this guy, that's another buck supply. I got another one, but they're all basically stages of boost and buck converters that have no isolation. The only reason they're isolated is because I've got them running from batteries, you know. So technically, this would be a cool little deal where I could use it the same way. I suppose if I didn't use these FETs like a retard, then I could have put, you know, up to 30 volts or more out of it. Maybe even made it a little boost converter, right? But still isolated. I'm not too amazingly jumping for joy about it, but I'm happy enough with how that worked out. I didn't have to go crazy in the feedback loop stability. It actually still even worked fine when I had the damn thing wired wrong value cap and all that, right? But of course, you know, I'm limited by the total output power. I'm just not going to be too worried about that right now, right? Maybe in the future, if I try to build a bigger one, which obviously will come, I need to build a smaller one and then a bigger one. Maybe I'll see if I can push a lot more power out the other one, right? All right, so this basically ended up being how my feedback is set up with this circuit. So I ended up just putting a whole bunch of output caps. I got it but I got these huge shotkeys right here. So I'm full wave rectified. I've just added a 1K output resistor. Not sure if that's really making a difference, but I figure why not. So as far as the 817 basic opto and the TL431, I'm using a 2K off the V out positive, going through the anode, cathode to cathode. And you can see the anode of the 431 going to straight to V out negative. And then you can see how I've got my positive out to this little Rio here. So I put a 20K pot in series with a 2K. And then I've got a 2K on this end from ref to anode. And that gives me that approximate, 5 volts DC up to 24 volts VDC with my again, my 24 volts in is what I'm looking for. And then, I've just strapped another little 10K off the V out plus over to the cathode here, hoping that that'll always have a little bit of current. And then from what I've noticed here, just based on these values with this opto, this 2K, seems like I'm fine going all the way down to 5 volts. It seems like nobody's like really starving over here. But that was totally unloaded. Who knows, man? Who knows what could happen there? So that's essentially what I ended up with. So I'm using, the collector out, just going over to pin 2 of error amp 1 on the TL494. And then I've got a, I've got, for pin 1, I've just made a 2.5 volt divider off the pin 14 VREF, right? So a couple 10Ks. And then error amp 2, I've just grounded out. And that's just how this is set up, right?